Hi folks, I apologize for not being here today. Personal reasons took me away from the class, but today's lesson's really, I figured you guys could handle this without me because it is simply just applying all of the skills that we've learned so far on Monday, Tuesday, Wednesday, and we're kind of putting them all together in this lesson of 2.4. So in 2.4, we are solving a triangle. So when you're solving a triangle, you have to solve for all missing sides and all missing angles. That's the really important part here, is that you have to do it all. Not a big deal. I'm just trying to get my calculator in the right mode. I remind you while I'm doing this is that you want your calculators to be in degrees. If you're using one of my calculators, chances are they're in radians because that's what we've been doing with the grade 12s. So I'm just going to show you on the display screen. Oh, that's really dark. Maybe I'll turn on some lights. Ah, there we go. That works. Okay, so on my calculator, it has an R. That's not what I want to be in. That's for radians. I want to be in degrees. So please make sure you are in degrees. Oh, geez. Now I got to figure out on this calculator how to do it. Okay, so for this calculator, I had to hit shift mode, and then I'm gonna pick option 3, which is degrees. You're gonna see different buttons. We will have gone through this with the class already, but I just wanna remind you that you wanna see a degree, a D on your screen. So DEG or D. I'm gonna use my graphing calculator, and mine, if you notice, says it right across. Oh, why is this? It was beautiful, and now turn those lights off. Okay, there we go. You see mine along the top says degree, so I know what one I'm in. I'm gonna use my calculator just because it's a little bit, I don't know, it's the one I use. Okay, so solve for triangle XYZ. So XYZ is just the names of the vertices. Vertices is just the fancy name for corners of a triangle. We know that this box represents a 90-degree angle. So I'm going through a lot of things because we haven't started this unit yet. So if you feel that I'm repeating stuff, I apologize. Okay, so let's label our sides. I think that's going to be the most important thing. So before I start, so we have to pick what we're going to solve for first. I think I'll go ahead and I'm going to solve for x first. So you could solve for z first, no problem there, but you have to pick the angle that you want to solve for. Okay, so here's my 90 degrees. This side is my hypotenuse because it's directly across from the 90-degree angle. And it is also the longest side of the triangle. But I wouldn't go by longest side just because sometimes, especially if I'm drawing them, they're not drawn to scale. So here's my angle right here. The side that's opposite to the angle, so opposite, is right directly across from the angle we're trying to find. And the angle that touches, or the side that touches the angle is our adjacent side. All right. So like I said, I wanted to solve for x1 first. I want to solve for the angle x first. You can solve for z first. You could solve for the hypotenuse side first. It doesn't matter what order you do it in. I just started with x. So what I want to do is I want to solve for angle x. So I need two pieces of information. So the pieces of information that I have are my opposite side. Oh, there goes the bell. My opposite side and my adjacent side. So looking at my trig formulas, and maybe we'll write those right up at the top here. So sine of the angle is equal to the opposite side divided by the hypotenuse. Cosine of the angle is equal to the adjacent side divided by the hypotenuse. And tangent of the angle is equal to opposite divided by the adjacent side. All right, so I know all those. And so what trig formula has adjacent and opposite in it? Because that's the pieces of information I have. I have my adjacent and my opposite. So that's going to be my tan. So I'm going to fill in the information that I have. So I'm finding tan of angle x is equal to the opposite side divided by the adjacent. And I think as we're learning, and this is always my recommendation, I think as we learn, it's really important to write down the formula first, because that's going to embed it in your brain. The more times it's the muscle memory, you're going to write it down, you're going to say it in your head, you'll commit it to memory. So we're going to put in opposite. It matters, ladies and gentlemen. It matters where these go. So if adjacent is at the bottom, then your 6 has to go on the bottom. Okay? You can't flip-flop these because then it's a totally different ratio. And when I talk about ratios, ratios can be represented with a colon, or sometimes we are looking at two things, we're comparing them in a fraction state. That can also be referred to as a ratio as well. Okay, so if we're solving for an angle, we need to use our second function button in the calculator. Okay, and I represent by using the second function button tan to the -1. I still encourage my grade 12s to write that step down because it reminds us that there's an extra step. So we're going to go ahead and we're going to round to the nearest whole degree. So I'm going to hit my second function. You may use maybe a shift on your calculator. And if you look, tan -1 is right above the tan button. So I hit my shift. You can see that that's indicated shift. Mine shows me that. And I can put in the fraction 10 divided by 6. And I'm just going to close my bracket. Got to make sure I'm in degrees. And I'm going to hit enter. All right. And we said we're going to round to the nearest whole degree. So this is going to be 59. And I need the degree symbol. This will come into play later when you are in my grade 12 pre-cal class and we're talking about radians because they have a different unit of measure. Okay, so that's pretty easy, straightforward, but I haven't solved the triangle yet. I've solved for one angle. Good thing is we know the rule of one, sorry, bells. You know the rule of 180. Or maybe you don't know the rule of 180. I'll say it again. We know that all interior, so interior means inside, so all interior angles in a triangle add up to 180 degrees. So all interior angles add up to 180 degrees. And we've found 2 out of the 3. So super easy. We're going to have 180 is equal to 90, because that's my first angle, plus the 59 plus angle Z. So we can do some math, and I'm okay with however you choose to do it. I always cross my Z's so that you know they're not 2's. Minus 149. Ooh, I forgot my degree symbol there. Minus 149 from each side. So we are going to have Z left on that side. And 180 minus 49 is going to be 31. So angle Z has a measurement of 31 degrees. We can use trigonometry to find it as well. There's no problem with that. You can totally do it. And we'll get approximately the same answers. And I say approximate because we're doing some rounding here. I'm going to erase that and put 59 degrees. So if I add all these up, oh, that should be, oh dear. That should be 21. That was my mental math. It's terrible. It's a good thing these are erasable pens. It's a good thing these are erasable pens. All right, that looks better. All right, so just to double check to see if I made a mistake again. So I have 90 degrees plus 59 degrees plus 21 degrees. Okay, it was 31. Geez Louise. Geez Louise. So it's a good thing I know that all interior angles add up to 180. Let me erase that. Add up to 180, because then I can check to make sure that my answers are correct. All right, so with this one, now the only thing left to find is the length of our hypotenuse. The length of our hypotenuse. Okay, so we can use trig, or we can use Pythagorean theorem. And I'm going to show you how to use trig, and then we'll do Pythagorean theorem just to be safe. Okay, because again, it's always good to have ways to check your answers. And if you do it multiple ways, you don't have to though. Like you don't want to spend 10 hours doing this assignment. Okay, so we're trying to find the hypotenuse. It doesn't matter at what angle we use. We just don't want to use the 90 degree. We want to use the 59 or the 31. So I'm going to use the 59, and I'm going to use the 10. Again, I could have used the 6. It doesn't matter what two pieces of information you use, but you need two in order to find your third. So I have my opposite side. I know what my opposite side is. I know what my angle is, and I'm trying to find the hypotenuse. So what trig formula has opposite and hypotenuse in it? So if I look up here, my trig formula that has opposite and hypotenuse is sine. So that's the one I'm going to use. So sine of the angle is equal to opposite divided by the hypotenuse. So now I'm going to fill in the information. Again, I always write down that trig formula first. So sine of 59 is equal to opposite, which is 10, and the hypotenuse I don't know, but it's side y, because it's directly across from the vertice y, so it is the lowercase letter y. We will have covered that in something else, in another lesson, I'm hoping. Okay, so because I'm not solving for the angle, I'm not using the second function button. So in my calculator, I'm going to simply put in sine, so I didn't use second function, sine of 59, and I'm going to get this really long decimal. You need to use all the places of the decimal. Okay, so, but here's the thing. You don't have to write them down, but just know that that's the math that we're going to have to do. I need to get y off the bottom, okay? So we're going to do a little bit of algebra here. So if y is divided by y, the opposite to dividing by y would be to multiply by y. If I multiply the right-hand side by y, I have to multiply the left-hand side by y. So those will cancel each other out, and I'm left with y times sine of 59 equals 10. So I want y by itself, so I want to get rid of this with that. So if they're multiplied, the opposite to multiply is divide. So y is equal to 10 divided by sine of 59. So I didn't write down all those decimal points because that's a lot of stuff for me to write. This is the actual math that I'm going to do. So I can actually do it all in one step in my calculator. And for side lengths, we're going to round to 2 decimal places. So I can go 10 divided by sine of 59. I just got to make sure I close my bracket, and it will do that for me. So this is 11.67. And there are units of measure on here. So they're listed as centimeters. It's really important that you list your units of measure. So there are the 3 pieces of information that I needed to solve my triangle. 2 angles and 1 side. So that one's done. Okay, I'll try to go a little bit faster for this one. And at any point, if you need to pause the video, please feel free to do so. So when I'm looking at this one, the angle 25 is in here. The angle was too small to actually write it in. So we're looking for angle D. We're looking for side D, and we're looking for side F. Now, first thing I'm going to do is I'm going to label, the first thing I'm going to do is I'm going to solve for angle D, because what do we know all interior angles add up to? 180, and this time I'm going to be better at my mental math. So I have 2 of those angles. We know the box represents a 90-degree angle, and we know that this one is 25. We know that all 3 angles add up to 180. So I don't know. I think adding and subtracting is a little bit easier than doing trigonometry. But again, you can use trigonometry if you want. Both will work. Oh, I said I was going to use Pythagorean theorem here to do that. Okay, we'll get everything done and then I'll go back and use Pythagorean theorem. Okay, so 180, 115 plus d, so minus 115. I keep forgetting the degree sign on the 180. It's really important that your answer has it. It's not super duper important that you have the degree all the way through. It's really super duper important that your answer have it. Okay, I think I did that one right. But last time I wasn't so sure, so I'm going to double check with my calculator. 180 minus 115, 65. Okay, my mental math is pretty good. Okay, so I have my angle. Super good. Done and done. Okay, now that we have that, let's solve for some sides. Okay, let's solve for side D first. I don't know why I picked D, but that's the one I'm going to solve for first. So I'm going to solve for D first. So I need an angle, but it cannot be the 90 degrees. So it's either going to be the 25 or the 65. It doesn't matter to me which one you use. It will affect what trig function you use. So if you pick 65 and I pick 25, we'll get the same length for D, but you'll use a different trig ratio than I will. So I'm going to use angle 25 and side of 5. Okay, so before I can pick my trig formula, I need to figure out what sides they are. So if I'm using angle 25, I know side F is the hypotenuse because it is across from the 90 degree angle. I know that side D makes up the angle, so this has to be the adjacent side. And so that would mean this is my opposite side. Okay, so what do I need? I need opposite and adjacent, and that's my tan formula again. So tan of the angle is equal to opposite divided by adjacent. I would make sure that you have this written down on a little piece of paper somewhere that you can always flip back and forth to as you're learning. I know them because I use them a lot. So if you're still struggling to figure out which one, ask me and we'll walk through it, or use your diagrams from lesson 2.1. Okay, so we're going to fill in the information that we have. So tan of 25 is equal to the opposite side, which is 5, over the adjacent side, which is the letter D. So again, before I do anything in my calculator, I'm going to manipulate this formula. So I'm going to times both sides by D. So those will cancel each other out. So I have D times tan of 25 equals 5. I want the letter D by itself. Oops, got a little crazy there with my line. So I'm going to divide those out, so those will cancel each other out. But whatever I do to one side, I have to do to the other. So D is equal to 5 over tan of 25. So again, my calculator can do this all at once. So I'm going to use my handy dandy calculator. 5 divided by tan of 25. I got to close my brackets. And we're going to round to the second decimal place. And we're going to make sure we put in our units of measure. So 10.72 centimeters. Okay, so there we go. So that's really good. Maybe I'll show you how to use Pythagorean theorem here, because we can. Okay, so I have one piece of information. I have the second piece of information. I want to find the third piece, which is my hypotenuse. Now, Pythagorean theorem, I think you learned in grade 7 or grade 8. And if you don't remember it, again, you can still use trig to do this. This is just another way. So you can use a squared plus b squared equals c squared. So this is Pythagorean theorem. And you should have learned it in grade 8, grade 7, somewhere along there. If you don't remember it, it's totally okay. You can use trigonometry, but Pythagorean theorem is a really handy tool that we use a lot in other classes. Okay, so the most important thing about Pythagorean theorem is this, side C. Side C has to be the hypotenuse. Has to be the hypotenuse. You can switch A and B, those can be your opposite or your adjacent, those can switch places because they're added together, but C has to be your hypotenuse. Okay, so pretty straightforward. We know, I don't know, we'll put 5 in for A, so 5 squared plus, what's the other side? The adjacent side is 10.72, so 10.72 squared equals C squared. Don't forget your squares. It's really easy to forget about them. All right. So I have 10.72, and I'm going to square it. So square it means to times it by itself. So in my calculator, I do have a squared button, so I can just do that. And I'm going to get 114.9184 equals C squared. So I'm going to go ahead and add those together. So I'm going to add 25 to it. You guys can't see that. There you can, now you can. 139.9184 equals C squared. All right, I don't want C squared, I just want, maybe I should remove that line. I just want C, so in order to get rid of a square, we do the square root. I'm going to square root this, square root this. So that will just give me C. And now I have to square root that number. And I have this nice fancy answer key, so it takes the answer from the line above. And I get an answer of 11.83, because I'm going to round to 2 decimal places, centimeters. Don't forget your units of measure. That's pretty exciting, eh? While we're here, though, and I have your undivided attention, I'm going to do this using trigonometry. So the number we got for the hypotenuse, we had a measure of 11.83 centimeters. All right, so what I'm going to do now is I'm actually going to go ahead and solve for the hypotenuse with the information that I have. So let me grab a highlighter. I'm going to use angle 25. I'm going to use side 5, and I'm going to solve for the hypotenuse. So trig formula that has the opposite and the hypotenuse in it, because I keep using that same angle, so this still is opposite to 25. Those are opposite to each other. So opposite and hypotenuse is sine. So sine of the angle is equal to opposite over hypotenuse. We have sine of 25 is equal to 5 over the hypotenuse, which is the letter F. Okay, I'm going to rearrange, so I'm going to multiply both sides by F. Those cancel each other out. I'm left with F times sine of 25 equals 5. Divide out that sine of 25, because I want to get F by itself. Okay, now I'm going to do that in my calculator. Now remember, using Pythagorean theorem, we got that for an answer. So I'm going to do this in my calculator. I can do it all in one step. Sine 25, close my brackets. And I get the same answer. So both methods are very valid. Pythagorean theorem, you need 2 sides and no angles. In using trig ratios, you'll need an angle and a side. So it really depends on what information that you have. So there's a couple of things that you can do different ways, and we all get the same answer. I hope this is helpful. I hope you guys are successful. And don't forget, you've got a quiz on Monday. Okay, have a great day, guys, and enjoy your Friday off.